Okay, today we're going to talk about cloud computing. Cloud computing is a really cool sounding name for a really simple idea. Like the sticker says, there is no cloud, it's just someone else's computer. What cloud computing really means is that you're purchasing time or space on servers in somebody else's data center. And that's all it is. What it really means is computing as a service. You're paying money for computing time for space on this other data center rather than having to own the hardware and maintain the hardware and the software and all of that stuff yourself. So why does cloud computing happen? Why do we have it? Primarily because of the extensive costs of running a server, or especially of running a data center with multiple servers. So you've got costs for hardware, you've got costs for software licenses, you've got to have a place to put the servers. And then when you've got a place to put the servers, you have to secure that space. So physical security is a big thing. You have to have power, you have to provide cooling because servers can't be overheated or else they stop working. So cooling in server rooms is a big deal, securing the server rooms, preventing water from entering the server rooms. There's lots of issues to do with managing a server room. And then you've got administration, systems administration. People are expensive. You have to pay benefits, you have to pay for insurance, you have to pay for time off. And paying for those people is very expensive, so having dedicated administrators to manage this server room with the power and the cooling and the hardware and the software is another large expense related to owning and running servers on your own. And then another cost is hardware maintenance. Hardware fails. You have to upgrade things. You have to replace broken hard disks. And you have to have backups and make sure that when hard disks break, you don't have a problem. You have to manage all sorts of stuff. It's complicated, and there's a lot of issues that can happen that can cause problems if you are running your own computing infrastructure. Whereas with cloud computing, you're paying for this service, you're paying for a virtual machine, you're paying for a server running on somebody else's data center, and you can eliminate all of those costs, at least to some extent. You're still paying money for those things, but somebody else is managing them for you, and you only have to worry about having the resources that you need. So with cloud computing, really what you're doing is paying by the hour for server time. And it could be by the hour, it could be by the day, or whatever. The exact cost structure doesn't matter, but the benefit is that you don't have to manage, again, you don't have to manage hardware, you don't have to manage maintenance. You may not have to have any systems administrators. You may still want somebody on hand to manage the organization and to manage what cloud computing infrastructure you're using, but you can greatly reduce the cost of systems administration by moving from a self-hosted, self-run data center onto a cloud computing service. Another benefit is that you can easily scale up capacity to meet demand. Now, what does that mean? What that means, if you think about an average business is going to have high traffic times and it's going to have low traffic times. So think about an organization like Netflix. Netflix is not all that busy during the middle of the day. But at night, their usage ramps up a lot because people get home, they want to catch up on Fuller House, or they want to catch up on Breaking Bad, or they want to catch up on whatever show, House of Cards, that they happen to be watching. So their usage at night is when they're going to have their peak. And in the daytime, that slumps a lot. Well, if Netflix wanted to run their own servers, they would have to have enough capacity to manage all of that traffic that they have at night. And then during the day, that capacity would just be sitting there unused and eating up space, eating up cooling costs, eating up power, and essentially being wasted. Well, with cloud computing, at night, they can pay for more space on Amazon servers, and during the daytime, they can shut those servers down and not have to pay for them. and that allows them to easily scale up capacity to meet demand. Another personal story, Black Friday, a couple years ago, I wanted to build a computer, and I wanted to buy a bunch of supplies, a bunch of parts from Fry's.com. Fry's Electronics is awesome. So I went to their site on Black Friday, and their site was not functioning. And it was not functioning for all of Black Friday because they did not have enough capacity to meet that peak demand. Well, that's because most of the time, all year long, 364 days a year, traffic on Fry's.com is probably pretty slim. But on Black Friday, when they've got all those great deals, that traffic explodes, probably exponentially, causing their servers to shut down. Had they had a proper hosting agreement, had they had a cloud computing infrastructure, and had their site set up properly, they could have scaled up the capacity of their servers and scaled up the capacity of their website to meet that demand, and I would have been able to order my parts without spending the day frustrated that the website was broken. Another benefit with cloud computing, if you want to try something crazy or try something new or try out a new technology, you can very quickly, easily, and relatively cheaply spin up a server to try something out. And then if it doesn't work, you just kill the server, you shut it down, you tell the cloud provider to end it, and it's gone. And then you don't have to worry about it anymore, and that cost is gone. So it greatly reduces the risk of trying something new, as opposed to if I were buying the server myself, I would have to pay to purchase a server, and I would put that in my server room, get it all hooked up, and then if it doesn't work out, I've got this server sitting there. So who uses cloud computing? Well, you use cloud computing. I use cloud computing all the time. Dropbox is an example of a software as a service provider. I pay Dropbox $10 a month, and they provide me storage. They provide me storage on their servers, and they provide me with the software that I use to synchronize my files with their data center. And that allows me to synchronize my files across all my computers. Gmail is another example of a cloud service provider, of a cloud service, software as a service. So especially in the sense of Google Apps. So you guys have UN Omaha email accounts that use Google Apps, and the university pays Google some amount of money, I don't know how much, to use their servers for our email accounts. So rather than having to run their own email servers, we can just use those. We can use Google's. Slack is another example for the class. They provide this service to businesses. We get our free accounts, and then we have a free organization, but then you can also pay them $10 a month per user or something along those lines to have more features and better features and a longer history, I think, a few other features in their Slack channel. So for team communication, another software as a service. We also have Office 365. You can do the same thing using their online applications. You can edit and open Office documents. The last one here, OpenShift. You've used it for class. They're a platform as a service provider. We'll talk about what that means in just a minute. But they provide that online service, and you can push your application to OpenShift and have it available online. And you don't have to own the server. You don't have to run the server. And with this platform as a service, you don't even really have all that much access to the server. You're accessing just that little tiny slice that you need to open and run your application. So in the real world, who uses it? Well, just about everybody. All sorts of large organizations. Adobe uses it. Amazon uses it, obviously. They use web services, and they've created they are one of the largest web services provider as far as infrastructure and platform as a service through their Amazon Web Services. Airbnb uses it, Major League Baseball, NASA, and the Jet Propulsion Lab. And that's just a few. There's that link on the slides is a long, long list of organizations that use Amazon Web Services to do cloud computing. And it is huge. It's taken over the world. And whether you're a large organization that needs cloud computing to try out some new things or spin up some new servers, and you still have a large data center maybe in your organization that you've had for your legacy applications. Or if you're a small company, a small organization, maybe 5-10 employees or 2, and you don't want to have to purchase a server to start developing your awesome new web application, your awesome new social networking application, you could spin that up on AWS. And again, it reduces that risk because you're not locked into purchasing a server and having to manage and maintain that server. So I told you there's, I've alluded to a few different types of cloud computing, and these are the biggest ones. The broadest categories of cloud computing are software as a service, platform as a service, and infrastructure as a service. And you'll commonly hear software as a service referred to as SaaS. The other ones, I don't think they shorten those as much. But from left to right, you'll see you're increasing in the flexibility that you receive. So software as a service is the most restricted, whereas infrastructure as a service is very flexible. Typically you have a lot of options, and you're really getting granular in your control of your application and of your infrastructure. So with infrastructure as a service, what you're paying for essentially is a virtual machine or a database or whatever you need, and you get full access to that virtual machine. And there's several providers: Google Compute Engine, Amazon with their Elastic Compute Cloud, I think is what EC2 stands for, Microsoft Azure, DigitalOcean. These guys provide, you can purchase a virtual machine. And what that means is you have a computer stored on their servers, essentially. And you can do whatever you want. You have full control. You can log in, you can change software, you can add users, you can change permissions. You can do whatever you want on that server. So configuring whatever database software you want. Yeah, you're free to do whatever you want. What that means, though, is that you have full responsibility. Typically with infrastructure as a service, once you spin up that instance, or once you purchase that virtual machine, you're responsible for whatever happens on it. So if you have a security vulnerability in your application, then you're responsible for maintaining that. You're responsible for fixing your application. If there's a security vulnerability in some software that you install on that server, on that virtual machine, well, that, again, is your responsibility. We'll talk a little bit about who has what responsibility a little bit later on. But the most important thing to understand is that with infrastructure as a service, very often you are responsible for anything that goes wrong with your server or with your service. The next up is platform as a service. Like I said, this is what OpenShift provides. And what this gives you is a very limited machine. And they might call it a machine, they might call it a gear like OpenShift does, or an application. And what's really happening here is they are restricting. So rather than giving you this full virtual machine that you can do whatever you want, they're restricting your access to that and restricting what languages you can use, for example. So we spun up, for this class, we've spun up a Node.js instance or a Node.js application. And within that, we can use Node.js. And then we added on top of that, we added that MySQL appliance so that we could use the MySQL database. And then we added PHP MyAdmin. But we're very limited in terms of what other software we can install. So we can use that language, but if we wanted to create a PHP application, we'd have to spin up a separate gear for that. So it's a limited environment where the provider of the service determines what languages that we can use. So if a new language comes out tomorrow, you probably won't be able to spin up an OpenShift instance to try it out, to deploy an application. So you might be also restricted in what libraries you can install or what libraries you can use within a language. So with OpenShift, they provide Perl, they provide PHP, Python, Ruby, and Node. And those are officially supported languages by OpenShift. And what that means is they will provide updates. So if there's security updates and vulnerabilities discovered in Python, for example, or in Node, they will apply the patches to that on their instances to prevent widespread security vulnerabilities. Unlike in that infrastructure as a service where you're responsible for everything, they're going to provide that service and lock that down for you. There are also community-provided languages, something like Go, a newer language, and those are not officially supported by OpenShift, which means you may not get those security patches or the latest updates to your application or to your language environment. But OpenShift has enabled other people outside of themselves, outside of the organization, to provide languages for you to use. So then there's also, finally, software as a service. Now, software as a service provides you an application over the internet, and that's all it is. So you are paying to use an application over the internet. Typically, you're doing that through a web interface, and all of the upgrades for that application are provided typically with the service. So Google Apps, like I mentioned, is one example. The university pays Google, I don't know, $10 a month per user for Google Apps. And we can use Google Drive and we can use Gmail within UNO. And unomaha.edu email addresses are provided through Gmail, and you can link it up through there. Another common example is Salesforce, salesforce.com, and we'll be using that for another assignment later on in the semester. And they provide a couple platforms. We'll talk a little bit more about those in just a minute. Dropbox is another example, like I mentioned. Slack is another example of a software as a service, where as a team you can pay for this communications application. And like I mentioned before, this is the least flexible option. You are provided one application. With a platform as a service, you're developing the application, and you can develop using essentially all of the features that language provides. With software as a service, you are given an application. You're paying for an application, and you are given whatever customization options are provided by that application, and that's it. So Salesforce.com, they provide this application. It's a customer relationship management application, and you can manage essentially everything to do with customer relationships. So you can manage advertising, you can manage capturing leads from your website and pulling those into this CRM application to allow your salespeople or whoever to follow up with leads and turn those people into customers, manage sales, and keep track of who has subscriptions and who needs to renew subscriptions and who's managing and contacts, and all of that information can be tracked inside of Salesforce so that you can have a customer relationship management application without having to host it and run it yourself. And Salesforce has been wildly successful in selling this software as a service. And they've been wildly successful in part because they provide all of this infrastructure very effectively, and in part because they allow people to customize those applications extensively. So everybody can manage their own application. So in addition to the customer relationship management application, the folks at Salesforce also have expanded. So this happens all the time. You get your service up and running. It's essentially how AWS, Amazon Web Services, came to be. Amazon had developed all of this infrastructure for scaling up and scaling down their website and the services that they provide, and they decided to make some money on the side by selling those services to other people. Well, Salesforce has done the same thing. They've developed a new platform that they call Force.com that allows you to develop entire applications separate from the Salesforce application, entirely new applications through their site. And you can develop and you can test and you can sell these applications to other people. So it falls somewhere, kind of straddles the line between platform and software as a service because it's an even more limited environment than you would typically see with platform as a service, where they're providing an application development environment, but it provides more customization than you would typically see with software as a service as well. So it's somewhere in between. And force.com is what we're going to use for another assignment later on. So there are important considerations when you're thinking of going to cloud computing and when you're thinking of moving from a self-hosted environment where you're in control of everything to a cloud computing environment where you have less control. So first of all, you have to consider that this is what's called a multi-tenant environment. Now, depending on whether this is infrastructure, platform, or software as a service, the amount of interaction or connection between data is different, but you have to consider that your competitors might also be using the same applications. So you might have people in your same industry using Salesforce.com, which means that your information and their information is in the same place. It's in the same database. So important things to consider in this multi-tenant environment are data isolation. Or if you're developing an application, or if you want to develop a cloud service or a software as a service application, you need to consider data isolation. You need to make absolutely sure that one customer's data doesn't interact or get contaminated with or see or have access to another customer's data, because that is a huge security risk. You want to make sure, absolutely sure, that data is isolated by customer. You also want application isolation. So as customers are customizing their application, as I'm adding new features or turning on plugins or customizing the way things show up in my version of an application like Salesforce, that had better not have any impact at all on another customer's version of the application and their interaction with the application. And then you also have to consider performance isolation. You want to make sure that if one customer starts using the application a lot, that's not going to affect the performance of other people who want to use the application. And then another consideration is regulatory requirements. So if you're in the healthcare industry, you have to deal with the privacy requirements of HIPAA. If you're dealing with credit card payment information, then you need to deal with the requirements of the payment card industry with PCI. Sarbanes-Oxley provides a whole bunch of requirements for accounting data. And you need to make absolutely sure that regardless of the cloud environment, you need to make sure that you are meeting the requirements of your industry and whatever regulations that you need to follow. Because the HIPAA people, the HIPAA enforcers, don't care that you're using the newest, coolest cloud services. They only care that you are following the rules of HIPAA. So another thing to consider related to the risks of cloud services is what happens if something happens. What happens if something goes down? So a little while back, September 2015, there was an outage at Amazon Web Services. And that meant that Amazon, Netflix, Tinder, a lot of services that relied on Amazon Web Services for their computing went down and stopped working. So you need to make sure that you're going to be using a reliable web services provider. And also another concern is keeping access to your Amazon Web Services account secure. So we've talked about it already, but if you're using GitHub, if you're using repositories, and those are public repositories, then you need to make sure that you're not putting your secrets, your secret keys, for your Amazon Web Services account in your GitHub repository, because that becomes public. So here's an example. That top headline there, my AWS account was hacked and I have a $50,000 bill. So this person lost access to their private key, and somebody spun up a whole bunch of AWS instances to do some computing, maybe some Bitcoin mining or something along those lines, and over one weekend racked up $50,000. So you need to make absolutely sure that access to your private keys is restricted and secure. So this is a Google search of AWS compromised, and there's a lot of stories of people losing access to that private key and thus losing access to their service. And this isn't a security weakness at Amazon Web Services. This is security weaknesses within the organization or within an individual who lost access to those private keys. So an important thing to look at when you're setting up service with a new cloud service provider is your service level agreement. And this is an agreement, a contract, that describes basically who's responsible for what and how much are they responsible for. So reliability is an important one for a cloud services provider. They better be promising you that they will be up X amount of time. Now, no service has 100% uptime. Everybody's going to go down. Even if you hosted it yourself, you're going to run into downtime issues. You're going to need to upgrade servers. You're going to need to shut down for security patches and things like that. It happens, but managing reliability and promises related to reliability are an important part of the service level agreement. Responsiveness is another one. How quickly will they respond if you submit a ticket and say there's an issue? Will you have a personal representative who's going to be your contact with the organization? Reporting, they need to be communicating with you if there are issues, when there are issues, how quickly and how much are they going to be reporting to you? And then in addition, you also have consequences for failure to meet obligations. And typically that's on the provider side. If they don't have the uptime that they provide, or if they're not meeting the responsiveness that they have promised in the service level agreement, then you have consequences, punishments, fees associated with that. So we have options with cloud computing, right? We don't have to have we don't have to go purely to the public cloud. And that would be if all of my services were on Amazon Web Services or Google Apps, and I don't have any of those servers myself. So we have another option, which is the private cloud, where I'm hosting all of those things myself. And what you can do with the private cloud is set up your own environment. You might set up file synchronization services within your organization or file sharing services within your organization on some sort of private cloud service. So some sort of private cloud application, rather than pointing out to Dropbox.com, for example, you can point that internally and share those only within your organization. And then you maintain some of the control, a little bit more control or a lot more control than passing that out to Dropbox. And then very often, most often, you're going to see something in the middle. So you're going to have some applications that are on the public cloud, some applications that are on a private cloud, and that we would call a hybrid cloud environment, where you're not doing all of one or the other. You're somewhere in the middle, and you're mixing those services as your organization demands and as you meet the needs of your organization. So what were some of the drivers that pushed cloud computing forward? So the biggest one, obviously, is widespread broadband internet. So now everybody's got not everybody, but most people have a broadband internet connection in their house, and that enables them to connect to these cloud-based applications. So cloud computing wasn't much of a thing when everybody was running desktops in their office, right? But now we have widespread broadband. Everybody has a high-speed internet connection to take advantage of these cloud-based services. And we can run applications on a data center in North Carolina, and everybody can access that very, very quickly. We also have AJAX, asynchronous JavaScript and XML. And what that is an environment or a way of running your application that makes it able to look and act a lot like a desktop interface. So without AJAX and without the JavaScript part of that, in order to, say, add a new customer to the website, you would have to go to a new page. Well, with AJAX, we can pop up a nice little form right on top of the page that you're at, add a new customer, add some new contact information, edit contact information, whatever, without ever leaving that one page. And that makes it look and act a lot more like a desktop web interface, and reduces the time that you're spending clicking between pages and waiting for the entire website and the entire page to reload with every action that you're trying to perform. And additionally, a big one, obviously, cost savings. Cloud computing enables economies of scale in terms of your computing infrastructure. So whether it's software as a service or infrastructure as a service, you've got an organization that is highly specialized in performing some service. So you have large data centers at Amazon with people who are extremely skilled at managing and maintaining servers. And you don't have to do that. And they can maintain servers for 15, 20, 100, 1,000 organizations all at once, rather than having each organization paying for their own systems administrator to manage the hardware in their organization and manage the hardware and infrastructure in their organization. So economies of scale enables those cost savings. Now, it's not always going to be a savings. Depending on the infrastructure, depending on what you need, you may be better off paying and putting in your own servers. But very often for a lot of organizations, it is going to be a cost savings. So the technology that enabled this to happen, besides Ajax, besides all of those other things that we've already said, is virtualization. Because with virtualization, you can have segregated or separated applications. You can have separated operating systems running on one specific set of hardware. So in your typical organization on the left, in your typical computer on the left, you've got your hardware like you have inside your laptop or like you have inside your desktop or like you have inside of a server. And on top of that hardware, you're running an operating system, Windows, OS 10, whatever. And on top of that operating system, then you run applications like your server applications like Apache, or your desktop applications like Office. And those applications are run inside of that operating system environment. Well, with virtualization, we have more of an environment like you have on the right. So you've got your hardware. Still, you need hardware, obviously, a processor, memory, storage. And on top of that hardware, you have what's called a hypervisor. And a hypervisor is a specialized form of an operating system that allows you to run multiple operating systems on top of that. So you might have, in this case, we have 3 operating systems. And each of those operating systems is completely separated. They can't talk to each other unless they're talking to each other through the network. So they can't talk directly to each other, unlike applications on a desktop might be able to talk to each other. And on top of those operating systems, you can run applications. So within this virtualized environment then, a company like Amazon can purchase a big, beefy server with lots of RAM and lots of hardware, lots of computing power and lots of storage. And they can sell multiple servers, virtual machines, running on top of that one piece of hardware. And so, again, pushing towards that economies of scale, multiple organizations can purchase a virtual machine. And then when you want to kill a virtual machine, you just delete the applications, you delete the operating system, and then those resources become available for Amazon or whoever the provider is to sell to somebody else along the line. And because those are isolated from each other, they're not interconnected, they're not dependent on each other. And you can create a new virtual machine, you can delete a virtual machine however you want, wherever you want. And you can move a virtual machine from one hardware, from one server, across the country, across the world, to another server, and have the same applications, the same operating system, the same exact environment running somewhere else almost instantly. And that's enabled the rapid expansion of cloud services as we use them today. So what can you do with it? Well, for one, you can run Windows inside of a Mac. So if you want to use Office, the newest Office applications, and Office for Mac is terrible, and so you use it on your Windows. If you need Windows for that, you can run a virtual machine that runs Windows. And that is, again, a completely isolated operating system that runs its own stuff. uses its own applications, and you can install Office on there and run it inside of that environment. Now, as far as the Windows is concerned, it's its own machine, it's running, and it's doing its own thing, and it can do all the things that Windows can do. You can also, using virtualization software like we have on the right here, you can run a whole bunch of different servers using virtual machines. So this guy's got a network attached storage, he's got a mail server, a Minecraft server, a firewall server, and a TeamSpeak server. And each of those are virtual machines running on one physical machine. And each of those, again, is completely isolated from each other. So you can screw up your Minecraft server, and your mail server and your pfSense firewall keep running without any issues. And if you have to reboot one of them, it doesn't affect the others. And that's the huge benefit of virtualization. So the benefits, like I said, we've got isolation of the environment for testing, for security, for experimentation. Again, you can spin up a virtual machine, do whatever you need with it, kill it if it doesn't work, or expand it if you find that it does work and you want to push and scale this application. Better resource utilization. Again, related to the economies of scale, right? You've got a server, and if you buy a big beefy server and you're running one small application on it, you're not using those resources very well. But if you have got a big beefy server and you can run virtual machines and run 12 low resource applications or low resource operating systems or whatever on it, then you're getting better utilization out of that resource. Super easy to set up and take down. You can create a test and a production environment where everything looks the same. And you can run, or more or less the same, at least more the same than if you were running in your own environment. And then finally, you can run multiple computers and see how they interact. So in my networking classes, I have people set up virtual machines, and those virtual machines talk to each other, and you can see and simulate a networking environment. So who uses it? Basically everyone. There's web hosts. Any web host that you're doing is probably using some form of virtualization, whether it's DreamHost or HostGator. If you're purchasing a virtual private server from somebody like DigitalOcean or AWS with their EC2 instances, the virtual part of virtual private server is a virtual machine. That's what you're purchasing, is a virtual machine on their servers. Companies like Adobe and Symantec use it. UNO uses virtual machines. Everybody, government, private organizations, education, everybody is using virtualization. It is huge. And it's because of all of the benefits that it provides, whether it's security or experimentation or configuration. All of those benefits just make virtualization such an awesome solution for everybody. I say everybody. It's not actually everybody, but a lot. The vast majority use or could be taking advantage of virtualization. So who provides it? Well, there's a lot. There's a lot of organizations that provide virtualization. If you want to run the software yourself, you can use Oracle's VirtualBox, and it's a free application, and they provide their enterprise versions as well, but they provide virtualization solutions. VMware is a big one. They are more focused on the enterprise. But I think they provide a free VMware player as well. And then finally, Windows Server with Microsoft, they provide what's called Hyper-V. And if you're running after Windows 8, I believe you can turn on Hyper-V inside of your computer and run virtual machines using the native virtualization built into Windows. So that's the end of our discussion about cloud computing. So we've talked about who's providing cloud computing, who's using cloud computing, some of the reasoning behind it, the different types of cloud computing, infrastructure, platform, and software as a service, and the technology behind it, and the primary drivers, and also the risks and some of the risks, costs, and benefits of using cloud computing. So now you're experts. You should know everything that you need to know about when, why, and how to do cloud computing, right?